So I'm here on Sunday and I'm running gels just to make sure that the lab worked. And, hi. I've loaded almost all of them so far. I figured I should record loading one of these so you all can see. So, I personally was using a whole bunch of different tubes. So I have a grand total of 6 tubes, so I've used 6 different tips. This is the last one. This is actually the K-. I have enough volume in here that I can actually do 2 gels. So, soft stop. I pull volume out. There's still some left. So, when I load the gel, I have to look straight down. Oh, I'm not good at this one-handed. So 1, 2, 3, 4, 5, 6. When I eject, I usually blow the air bubble out. Hooray, it all stuck inside. So I noticed with the K- when I went for the second sampling, there didn't seem to be enough. So what I did was I just respun it, and lo and behold, there's enough in there. So if you sit there and you say, oh wait, there's not enough, uh-oh. Well, the solution is spin it. Hooray, all loaded. So they've been sitting in the buffer solution. I need to now get these suckers started. So when you start them up, we actually have to add a lid to them. The lids actually turn out to match in terms of what goes where. So we just plug them in. So it's on, we're going to run it on medium. If you notice, we happen to have the positive terminal goes to red here, black matches up with black, hooray. But the bigger deal is there's a little wire in there made out of platinum, and if you notice, it's bubbling. That means it's working. No bubbles, we might be in trouble. I start to see some bubbles there. It's not as good as I want it to be, so I'll be monitoring this one. So for the gels, they start in the red on the black. What we say is we want them to run to red. So red is the positive terminal, DNA is negative, so it's going to go, due to Coulomb's law, we're going to move from the negative black terminal towards the positive red terminal, hence run to red. It'll take about 30-ish minutes. Hopefully I'll have something to show you after that. So I stopped them and they've gone for about 30 minutes. There's a faint yellow band that you can kind of sort of make out right there. That's actually part of the marker. Because we can't see DNA moving, what we do is we add a bit of a dye to the stain. The dye helps it sink to the bottom. And then what you can also do is use that dye as a tracker. There turn out to be several colors in there. You can kind of make out the yellow, and there's a blue right there. There's also a green somewhere in the middle. What you can do with the yellow is it's meant to represent really tiny pieces of DNA. So when it gets about 2/3 of the way down, we stop. So what I've done is I've placed the gel inside of something called a transilluminator, which is shining it with black light, and holy cow, look how pretty that is. This one right here is the molecular marker. This is A+, this one was K+, this one here was the ligation, minus K minus. Ligation, what we're hoping to do is make a big piece, and we've made a few pieces in there that you can kind of make out. This probably would have worked a little better if I let it run a little bit longer, but so duly noted. That's why I tested out first. Your goal is to get things that look like this. Oh, that's so pretty. So this one here was the second gel that I ran, and if you notice, there's doesn't appear to be anything in there. I did everything the exact same. The only difference between the two was this gel here. There, when in doubt, make it visible. So this gel here, I didn't add any of the stain directly to the gel. This one here, I did add stains, so maybe the difference, if we don't get results, or at least visible results, might be how the gels were made, as opposed to anything that you did wrong, because I did everything the same. The only difference was, this one here, I had gel, or the stain inside of the gel, and this one here, I didn't. But if I didn't do that comparison, I would have thought I totally screwed it up. But I didn't.